analyzers. Hope you're having fun with completing the square day one. Now we're on to day two. We're going to use those perfect square trinomials to solve our quadratic equations. I love solving by completing the square, but when I was in high school, I didn't. I love it now, though. It's the best one. It is. It's the best one. You get your perfect square trinomial and you take the square root of both sides. Done. So here we go. Let's get a perfect square trinomial, right? Let's factor it into its two binomials that are the same binomial. That's what makes this part so fun, right? What are the factors of 49 that add to give me 14? Well, 49 is a perfect square. It's 7 and 7. So x plus 7 times x plus 7 are my two binomials. And because they're exactly the same binomial, I write them as one binomial squared. What are the factors of 100 that add to give me negative 20? Well, that would be 10, right? X minus 10 and x minus 10, which is the same binomial. So I write it as one binomial squared. I'm going to ignore those two because we're actually not going to use those when we solve momentarily, but they exist. This is what you did yesterday in day one. Fill in the blank. Tell me the C term. You take the B term, divide it by 2, and square it. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. Big hint I didn't say yesterday, too, that's actually going to make this a lot easier on you, too. Filling in the blank is always going to be a perfect square. If your B term is odd, it's square the odd number. 9 squared is 81. Put it over 4. Because 2 squared is always 4. So that's always going to be your denominator with these. There you go. 12 divided by 2 is 6. 6 squared is 36. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16. Always a positive that goes on that line. It's always a positive that goes on that line. Okay? Because negative times negative is also positive. So it's always plus that C term. Now you're just going to have to worry about adding it to both sides of the equal sign. Okay? So there's an example right here that's already going to be done for you, and then you can see all my notes as it goes, right? So here's an example that's getting done for you where you had a trinomial that was not a perfect square trinomial. So what you did was you moved this C term over here to sit and wait. And what we did is we filled in this blank with an actual number that made this whole thing a perfect square trinomial. What that number was that we filled in on both sides was negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So 9 got filled in here and here. That made this a perfect square trinomial. And that was purposeful so that I could factor that thing into two binomials that were exactly the same. So that I could write those two binomials as one binomial squared. Because if I have one binomial squared, I can take the square root of both sides, and this whole thing, the square root and the square, just cancel out. These just cancel each other out, and all that's left is the x minus 3. It's purposeful. Creating that binomial squared is purposeful so that I can cancel out the squared by taking the square root of both sides. Now, when I take the square root of the other side, you have to remember to put the plus and minus in front of that radical. This happens to be a perfect square. 25 is a perfect square. So when I take its square root, I get plus and minus 5. That will not always be the case. But when it is the case, plus and minus 5 is two numbers, two integers, positive 5 and negative 5. So finally, I add 3 to both sides to get x completely alone. And this is 3 plus 5, which is 8, and 3 minus 5, which is negative 2. That means my two answers here are 8 and negative 2. Done. Now, this particular one had integer answers because my original trinomial was factorable. Okay? But that won't always be the case. And in fact, completing the square to solve quadratic equations is more commonly used for things that are not factorable. All right? And that's what we'll see. So we'll see lots of examples. And here my next example is something that wasn't factorable from the get-go. There are no factors of -4 that are going to subtract to give me a +8. So what I did was add that 4 to both sides of the equal sign, and then I put myself a little plus blank on both sides to fill it in by completing the square over here. So 8 divided by 2 is 4, 4 squared is 16. That goes in the blanks. And now on this side, you get a number, 20. On this side, that factors into two binomials that happen to be x plus 4 and x plus 4. So you can write them as one binomial squared. And once you've got that one binomial squared, you get to take the square root of both sides. And that's it. You know how to simplify a radical, and you know how to get your x alone by opposite operations. If you have an integer over here that then subtracts over, it goes in front of the plus and minus. See that? So the real number is here, or excuse me, the rational number is here. The irrational number is here. They are both real numbers. Sorry. They're both real numbers. I write my answers as -4 plus and minus 2 radical 5. I'll write my answers that way, but keep in mind this is two separate answers. Okay, so keep that in mind. This is two separate answers. So if you want to separate them, you may, to remind yourself that's two things. I will write as one thing in my French curly braces, but that's because I do know that those are two separate numbers. Let me just show you real quick. It's -4. Where's my mouse? There it is. -4 plus 2 radical 5. That's one of the numbers, and obviously irrational. And -4 minus 2 radical 5. And look at this one. Much different, two completely separate numbers. Again, much easier to look at them this way, but those are the two rational equivalents of that, the two decimal equivalents. Okay, well, let's move on. Now, like I said before, I was saying this when we were completing the square before, we can't have a number in front of our squared variable, right? So if you don't want a number in front of your squared variable, what you want to do is divide everything by that number. So the first thing I need to do here is I need to divide everything by 2 because I don't want a number in front of my squared variable. So I get p squared plus 24 equals 2p. Now, let's trade the 2p and the 24 because you need to have your squared variable and your middle variable on one side of the equal sign and your number on the other side of the equal sign. So p squared minus 2p plus blank, I'm going to fill in the blank in a sec, equals -24 plus blank. So remember, whatever I add to one side of the equal sign, I have to add to the other. So now, -2 divided by 2 is -1, and -1 squared is +1, and that's what fills in my blank on both sides. On this side, that's a perfect square trinomial now that factors to become p minus 1 times p minus 1. Well, that can be written as p minus 1 squared, which was my whole end game, right? That was the whole point, was I wanted that one binomial squared. But on the other side, I've got -24 plus 1, which is actually -23. So I bring that integer down from line to line. Now that I've got p minus 1 as a binomial squared, I can take the square root of both sides because what that does is eliminate the squared and just leaves me p minus 1. Done with that part. On the other side, don't forget the plus and minus in front. And the square root of -1 is I, so bring that sucker out. 23 is not evenly divisible by a perfect square at all. So that guy's going to stay stuck under there. But you still have to get p alone by adding 1 to both sides. This 1 you add to both sides goes in front of the imaginary number. So you get 1 plus and minus I radical 23. So my two answers here, 1 plus and minus I radical 23. Okay, those two answers are really 1 plus 1 plus I radical 23 and 1, oh my gosh, why can't I write what I'm saying? 1 minus I radical 23. There we go. Those are the two completely separate answers that I'm just putting that plus and minus between them. Oof. Imaginary answers there. That's why we had to have chapter 5 before we could do this. Had to know how to deal with those imaginary and complex numbers. All right, let's do another one. Oh, look, that was so nice of me. I kept the instructions on the page. Move that 1 over, subtract that 1 over. X squared plus 6x plus blank equals negative 1 plus blank. Fill in the blank. 6 divided by 2 is 9. How am I? Sorry, I was jumping the gun. 6 divided by 2 is 3. 3 squared is 9. That's what goes on the blank. Sorry, sometimes my head is just ready for that blank. So over here, that's x plus 3 times x plus 3. That, of course, can be written as x plus 3 squared, which was my whole goal. Meanwhile, on the other side, negative 1 plus 9 has been 8 this whole time. But once I got this guy, now I can take the square root of both sides. So square, those cancel. X plus 3 comes out. Over here, throw the plus and minus in front of it and simplify. 8 is evenly divisible by 4. What's the square root of 4? 2 radical 2 is our simplified radical. Chapter 4. Now to finish, get this integer over in front of your plus and minus 2 radical 2. So subtract that 3 over. It goes in front of your plus and minus. It cannot add and subtract with the irrational number behind it because it's rational. So these are two separate numbers as your answer. It's negative 3 plus 2 radical 2 and negative 3 minus 2 radical 2. Those are your two separate answers. I'm going to leave it like this as plus and minus between them, but again, two completely different answers right there. Whew. Guys, we got this. We got this. This isn't bad. Let's complete the square down here. I'm not going to solve these. I'm just going to complete the square, okay, just to practice. 16 divided by 2 is 8. 8 squared is 64. Remember, when it's an odd number in the middle, square the top over 4. So 9 over 4. Get negative 12 squared is 144. Okay. Divide everything by 4 first. Yes, that means a fraction over here, but I don't care. I don't care about that. I can deal with that fraction, okay? Oops, I forgot to put my plus blank in here. Hold on. Make room. There we go. And we'll put our x squared over here. There we go. Sorry about that. Didn't leave room for my plus blank. Now this is a 1, right? So 1 squared is 1 over 4. 1 over 4, look at that. That ends up being 2 numbers over 4 that I can add their numerators. So that's okay, right? But that's what I had to add to both sides. Okay, this guy, move the 6 over. X squared minus 4x plus blank equals negative 6 plus blank. Fill in the blank. Filling in the blank is a 4. That part, as you've noticed, just starts to become second nature when you do it enough. That making the perfect square trinomial needs to be that quick so that the rest of it is where you can spend your time. All right, practice solving quadratic equations by completing the square. Remember, that's my fave. This is the fun one. This is the fun one, guys. I mean, the quadratic formula is amazing and awesome and the best formula ever, but it's derived from completing the square. So you got to know completing the square to understand the quadratic formula. And it's part of why I think the quadratic formula is so amazing and awesome and the best ever. Obviously. I mean, I was thankful for it, right? Okay, guys. Good luck. I will be seeing you soon, but ask me for help if you need help solving your quadratic equations by completing the square. I think you can do it, but if you can't, I will remind you how. Bye, guys. Enjoy.